Hi guys, Josh from Speedway Racing. Just make another video. Just finished the assembly, nearly finished the assembly and the fabrication of a leader link front end for this little junior sidecar we're building. I'll sort of just do a video. I'll work backwards and just show you the process that I followed. I'll put a bit of thought into this one. It's a precision component, everything's precision. So the process had to be pretty spot on, like everything had to be two clearance, like two tolerance, minimal clearances. So it involved a bit of thought. So every thought I had, I sort of drew out. Once again, my book. Now I did come back every time. I did come back and change a few drawings. At the end, a few different notch angles and stuff that I ended up getting to. So firstly, I don't actually have a 4.5 inch centerline radius die. So shout out to Team Thompson Racing. Went over there. Did a bend, a U-bend quite a while ago now. Just sort of sat it to the side. Made it longer than I actually needed. And first step was to get the horseshoe square. So I've marked it out longer than I needed. Then it was a matter of engineer square on the table without all the round bar on it, to get it square, to get the end square, which I use the cold cut saw for. It was still lopsided a little bit, so take another mil. Still lopsided, take another mil, half mil, until I got it perfectly square, both sides, so I was happy with it. And what I did from there, had to drill a new hole in the table. I had 600 mil spacing for my clamps. Just drilled a new hole, and I was able to hold the horseshoe, clamp it down nice and tight, halve the diameter, use my vernier height gauge, scribe the lines where I wanted them, then I was able to flip it, get this square again, perfectly square again. You'll hear it when it's square, you'll hear a really nice ding. Yeah, like you'll hear it. Same with the notch, you'll hear it. It'll just click. You'll hear a click. It's sort of the sound you're looking for. Once I had it perfectly square again, clamped it, and I scribed intersecting lines at 90 degrees along the tube. I did this both sides, so I flipped it and did it all again. While I was there, also laid out my fork legs. This was just straight tube at this time. This was 1.5 inches. I clamped these down, did the same, flipped at 90 degrees at 19.05, half of 38.1, scribed it again. I did both ends of the tube. So what I wanted to achieve, I wanted to put them in here. I wanted to measure the center lines between the two legs, front and back, get them perfectly centered to find the true center of my fork legs. Compare that to the center of my horseshoe bar, which came out within 0.5 millimeter. It worked out really well. Couldn't have asked for a better result with that. They did aid me later on. I'll get to that later. From there, I bought an axle. This is a spacer tube out of an axle. It just came with the axle. It was out of a GP's at 1100 or something. This was my first intention to use it. It's 28 millimeters. I thought it was chrome, like a chrome moly. I did a weld test on it. It failed. It's hardened. I found that out when I machined it. So I'd scrapped that. Running back to Team Thompson Racing. Got some more chrome moly solid bar on credit. Put it on my tab. Thanks, Adam. I'll pay it one day, perhaps. We'll see. So these These ones I did machine. As I said, they're hard and they're really hard to machine. Didn't weld up very nicely, but they gave me a really good little template to use. So what I was able to do from there, use my lines in the notcher, set it up in the notcher. I was able to set it up with my level gauge. I was able to come through and notch it. One thing I did forget to mention here, I'll back up a step. I marked it all out first. That was my axle center line. I worked out 165 millimeters to my pivot point. Mark these lines out. Then set it up in the... No, I still didn't do that. I marked from the center line back to the notcher, and I gave myself a line so that when I held it one way, I held it this way, I had a line to go off, I had a marked line, I could use the hole saw there. Also marked the center, the same one here, so that when I flipped it over, I could line the same mark up in my notcher on my clamping block and get these two perfect. And then it was a matter of just filing it out a little bit until I got these to drop in nice with the axle in it. Make sure my notch was right, square off both sides. Make sure that was perfectly square. I was happy with that. These center lines for the pivot were all marked out. Then it was a matter of machining up these pieces. I need to machine this. It's 28 millimeters, 20 mil ID. These are 20 mil chromoly. But the trick with these is, this is an error. I made 2 of these while I was off site. The reason I like the drawing, I go off site a lot, I don't have a lathe. I'll take a photo, I'll jump on the lathe off site and I'll machine all these up. Unfortunately I only made 2 of these little 18 mil pieces, so I had to sit there and make the other ones with a pair of vice grips and a buffing wheel. It's a real pain in the ass. Don't want to do that again. But also made 2 of these instead of 4. Once I got to this point, I had these notched out. I was happy. It was all square. Checked everything out. I cut it back, to length first, and then marked all my center lines, notched it all. Gave myself clearance at the back of the wheel. I did have to pull that back. The modern senior ran about 35 millimeters clearance behind the wheel. So behind the back of the wheel here. The juniors had to really shorten up because I'm already nearly at maximum length. So I had to shorten the distance up here. I only probably gave it 20 mil or something rather than 35. So shaved a bit off that. Also, when it pivots, it won't hit my fairing, because I do have an altered steering head angle on this. So I needed to clear all the fairings, all the bar work, because the steering head is a little bit steeper, 60 degree on this one. So once I got to this point, it was notching these 2. This was tricky. So once again, vernier height gauge, worked it all out on my drawing, and set it at 21 millimeters. I was able to scribe, clamp it down again between this side. So I clamped down 21 millimeters, 21 outside on both of them. That gave me a visual index of how deep I could go, which I needed to do actually. Once I put it in the notcher, I couldn't hold it straight because it was a horseshoe. So I actually had to notch at an angle this way, angle that way, flip it around. Just because of the way I couldn't hold it properly in the clamping block, so I ended up having to work at an angle and then file them back out with the file and get them perfect. Once I got to that point, we needed them parallel this way. So what I used, 10 mil bolt, 125 mil, so I could exaggerate, and I could measure off the bolt both sides. It does fit. Both sides, then I could get parallel to the workbench, clamped down, and it worked out really well. Also, while I was there, I could square off my bolt, make sure they were square both this way. Once I was ready to tack these up, that's another story. That was a drama. Once I was ready to tack these up, I could fit the threaded rod in. I could adjust the nuts to get the spacing correct, because they needed to fit inside these two fork legs. And we don't want any sideways play either, so they needed to be pretty spot on. So all my centers lined up, I was happy with that. Determining the width inside the tube at 20 millimeters, that was tricky. That was very tricky. So what I ended up doing on that one, cut another piece. This way I could take it with me to the lathe and I could test fit them. So I laid it down, clamped it, measured my center line, then measured 10 mil above and 10 mil below. That way I could cut a bit of cardboard and just keep sitting there until I could get close to the right radius, chamfer radius, that it would actually fit in there and be nice and tight. I worked that out on cardboard. Ended up being about 31.8 mil. Once I fit them up, it came back to 31.7, pretty much on 31.70. So very good result. Worked really well. I was able to just place that in where I needed it. Cardboard helped me with that one. Had that also just to hand fit them on the lathe as I was radiusing the corners, and I could just keep dropping it in until I was happy with it. So from there, I was making a jig to weld it all up. So I just used 25 scrap stainless, used some of these off the little jig I made up for the rear of the bike. I was able to put it in, bolt it all together with the axle and tack it all up, get it all in place. Worked out really well. Once again, I was able to square off everything, clamp everything down. When I was welding, these blocks came in handy too, because I could set it where I liked, where I could just take off the table and just hold that horseshoe at that angle. That worked out really well too. That then gave me the measurement that I needed, stopped everything moving, but also gave me the measurement to machine my spacers, which I calculated and machined out. Everything fit together perfect. Didn't have to touch anything. It worked out really well. So then, had that pretty much complete, except the shocky mounts. I was moving on to these ones. This was fun. So, got some V-blocks here. I made these as an apprentice, one of the modules, just to make some V-blocks. Rarely use them, but they do come in handy from time to time. Just help you mark out. You can set off the bench, center punch and everything. So, I already had my center lines this way and this way. I marked front left, front right, where I needed to be. Had these made up, then it was a matter of drilling it. But it has to be perfectly on center. It can't be off, it has to be square, has to be on center. Once again, using the 125, I could square off and exaggerate. This is where I ran into an issue with this one. I got one. I chased the center a little bit. I could have done it in the mill. I didn't want to buy a cutter. So what I use, it's a prick punch. It's 60 degrees. It's a lot finer than a center punch. I already had my two lines, intersecting lines. because when I did that, this is where it ran into an issue. This is something to be mindful of. It needs to be perfectly square to the bench. So even if I had to use the square and use that, I marked my center point at 17 millimeters with a vernier height gauge. One worked out really well. I cut one. The other one, let's grab that. I want to talk to you guys, not debt collectors. So, where I ran into an issue, my first leg. This humbled me a bit, been doing this for 10 years. This one humbled me. What happened? Everything was going really well. I was really happy with how square it was. I was happy with everything, but I started chasing the notch angle. I took one off the Modern's, the Senior. It was 22 degree notch angle. I tried to sneak up on it, but I took too much and I cut into the hole. Also, I wasn't happy with the finish of the tungsten carbide die, the hole saw. So I changed it to a lot finer tooth one. So cut that off. I had an extra 50 millimeters, that wasn't an issue. I flipped it over. I still had marks. I still had all my other marks on it. I said, okay, I'll just drill another hole. Set it up again. Vernier height gauge 17 millimeters, which was already set. Scribed around the tube, and you can probably see it there. This got me unstuck. This was the cut that Race Tech Steel did when they sent it to me. It's probably just on a drop saw. It's not square. Once I scribed my line, I drilled my hole. You can see it's there. I should have checked. First rule of fabricating: patience. Always be patient. If you rush, doesn't matter how good you are at executing, you'll just end up without issues. Once I drilled my hole, this humbled me. Yeah, as I said, scrapped it. It was then too short. I'll use it for something else, but that went under the bench. Then I had to set up, clamp up, cut a new piece, start again on the other leg, which frustrated me. That's why I don't do live videos, because there'll just be a lot of cursing, swearing, plus me just sitting around thinking, drinking coffee, eating lunch, all that sort of fun stuff. It's easy to just do a recap. My son would probably watch it too if it's a 10 or 20-minute video. He might learn something. You might learn something. You never know. Once I got to that point, caught back up, had my second leg after I had lunch and a nap. Came back in, started again, worked out the notch angle, snuck up on a lot more so I didn't get caught out. Used the finer hole saw. I had all the angles worked out for the pivot and everything, but really just snuck up on it this time, so I didn't have to start again for the second time. So then I ended up pulling it back to about 21 degrees for my steering head angle. So I didn't want a large gap at the back here when it was sitting at 0. So 21 degrees, I was happy with how it sat. I didn't have excess clearance at the back. I had enough at the front for travel, for the suspension to work. But I still wasn't happy, so I just moved it and did, I think it was 20 degrees on the front. It was 20 degrees. So the way I achieved this again, I marked up from the square tube. I still had square at the time. Already had a 17 degree mark on this side. So I had a scribe line to go off. It's still there. It's still there. I marked it at 50 millimeters. Sat in the notcher, marked both at 50 millimeters. I was able to just slide it up, notch the angle, go off my clamping block, get both exactly the same, Then I did want more, so I moved it over to 52 millimeters and just took 20, so I took another couple millimeters out of that, just to give me more clearance at the front here if they really bottom the suspension out. So, welding, yeah. Welding these in, that was pretty simple, just put a bolt through it. They're all pretty tight. I was pretty happy with the finish. It's on centre. It's square. One good test would be lay the two on the bench. A little bit tight through there. It does go. Just square these, get welded into the 10mm. Need the bolt to go through one way. Swap the two around. Or vice versa. They need to go through both ways. If they don't, throw them in the bin. They're no good. And the tube should be parallel gap all the way. So that all worked out well. My plan worked. Everything went pretty smoothly except that fork leg. And the finish. I wasn't happy with the finish because it's going to be an exposed finish. So that just goes in the bin. Welding, yeah, what was I doing? I was welding these on. One issue I ran into, I'll make you aware of. I got porosity. I hit a bad spot. Must have been in the. I did turn this. Was 1.25 inch solid bar. I turned it back to 28 millimeters. I bought it and everything. I cleaned everything up, sanded it, had all my lines marked in my jig, tacked it all up. That all went smoothly. Did one fillet weld. That went well. I got to one spot on the tube. Must just have a bit of a impurity in the chromoly. I hit it with the welder. Although I'd sanded it, I metho wiped it, got it as clean as I possibly could. It started to blow out. And it was just frustrating. It was pretty frustrating in the final pass. So, filed it all back out. All the porosity, filed it out. Sanded it up again. Acetone wiped it. Hit it again. Went through actually cleanly that time. Once I filed all the porosity back out, gave myself a big groove in there, filed all the weld back out. It actually came back pretty well. That was the only issue I had really. Once you do weld, everything moves a little bit. As much as you clamp everything and do sort of the best you can to stop it, it will always want to pull. It'll just do funny little stuff. I had to tickle these out just with a bit of emery paper. I just used some 120, just on a bit of 16mm round bar. Lineaged these back out. And although I'd already mocked up and pre-fitted all, I just had to knock a little bit off this radius with the file because it was binding it a little bit in the leg after welding. Everything fit up well. Everything fit together well, no hammers involved. There was no excess clearance, so I was happy. Then was moving on to these plates here. So once again, get out the trusty cardboard, the old Cocoa Pops, marked it all out. You can probably see it on that one. That way. Mark it all out exactly what I want. Worked it out, cut it out, got my profile, happy. Show you one trick. I use 4mm plate, 5/32, whichever. Chromoly normalised plate. Tack these two together. 1, 2. Cut yourself a square. Always work with the square. It's easier than trying to hold this shape in the drill press and drill it after. Tack them together so they're one. So now you should have, 8mm. Trace out your shape you want, cut a square a little bit bigger. Mark out. Once again, I use a prick punch. I prick punch it really lightly with a small hole. Trace it around with my compass to get my radius that I'm going to lineage it down to. As you can see, yeah, it looks like a laser cut piece. It's just done by hand. Just take your time. no rushing. Compass, do your radius edge, the tangent of those lines, mark the rest out. On a tacked up square. Once you've cut your square out and it's all holding together, drill your hole. What that allows you to do is put a small bolt and bolt your plates together so they're still one, and then you've only got a tack on your corner. So I had tack on this corner down here. What that allowed me to do, cut all the rest out just with the angle grinder, had the two bolted together as one, lineage all the profile, and you will get two exactly the same pieces. Once you separate them, you can countersink and then just run. If you're not happy with the radius a little bit, if you weren't quite square, 90 degrees on the wheel, on the lineager, you can just nip it up a little bit and run all the way around, deburr it, center, what's the word, sorry, countersink, that's the one, countersink, and then just deburr. I also run over just with a bit of sandpaper afterwards, just to give myself that finish. So that's another little trick. Always tack them together, work as one, drill your hole first, bolt them together, cut them out as one. Once you're done, undo it, break your tack, and you've got two identical plates. So that pretty much wraps it up. What's left now? Actually, I'll talk about it. What I did now, as I said, I had the 50mm extra on there, which sort of would have worked pretty well if I could have flipped it and had a square edge to work on that second leg. You got me out of the poo. I put the bolt through again. I measured my height I wanted, so I get them perfectly the same height. What I've done now, I've just made a cap. Same process, prick punch, compass with my test and tag pen. What I've done here, I've cut it 1mm smaller, so that it goes on. I actually want to 90. I want a 90 when I cap this, and I'll pull that material down and I'll end up with a radius corner. If you have it over one side and you pull this material down, it's going to sit over and you're going to be buffing it back. You won't have much much strength in your cap anyway. It's only a cap, so it's not an issue, but you won't be buffing it off. You'll have your 90 in that corner and you'll just roll it and you'll end up with a nice rolled edge. You'll barely have to buff it. Of course, I'll put my prick marks on the inside, so that won't be an issue. You'll never see them. Just one more thing. I'll briefly touch on before I put you all to sleep. Going on too long. I did have an issue a while ago. I rushed. I was impatient. I didn't clamp my cold cut saw. I didn't clamp my steel properly on a little piece I was just cutting to make a little holding piece, just a little, and it bucked and I ended up chipping out 3 teeth. What that did, put my blade a little bit wonky, so it's not really an issue until I want to get a really precise square edge. Luckily I cut this before I damaged the blade. When I say I damaged the blade, the cold cut saw cost $600, $700-ish to buy from Total Tools. Replacement blade from Total Tools, Diablo 60 tooth tungsten carbide, was about $260. So my advice, shop around. I got a replacement one after I damaged it on eBay, $180 with 20% off. So I ended up getting it for about $150, $160 for free shipping. So I got a replacement for nearly $100 less than Total Tools, just because I shopped around a little bit. I didn't want to be caught out again buying a blade worth half the price of the saw. So I've just used it today. It hasn't really been an issue until today, when I really wanted some precision stuff again. What I've got here, 75 by 50 RHS. I've got my trusty pen. I had to square the blade again because my zero is not quite zero. So as accurately as you can. Mark your line, mark an intersecting line down the other side. You don't have to cut on this line, but you know, you square off another line, which is what I've done here. You'll see the line. It actually helps if you don't cut on the line. Then you can re-zero your zero scale on your sort of clamping backstop or on your miter bit. So I did one cut, was a little bit off, and you can see how straight it cuts down the side there. So that's the cold cut. The cold cut compared to, I think this was a steel place. It's just on the piss. That was an abrasive saw wheel, just a hot saw. What they tend to do when you cut, they tend to flex, and you will get an angled cut every time. You'll cut it and you'll just get an angled cut. You can't really work with it. I don't want that, especially after that episode with that other fork leg. So I re-zeroed it today. I laid it down, I cut this way, I checked it. I had to move it a little bit, remarked it again, cut it, got it really happy with where I wanted it. 50 millimeters, it's square down the backside, square across there, so when I cut this, I know that it's going to be nearly not as good, but nearly as good as a machine faced edge from the lathe. It'll give me something to work with rather than having a cap that's a little pissed and bug me. Another reason the cold cut, as I said, the wheel does flex. I don't like it, but this is my damaged one. It's still fine. It still works. I put it away just for a rainy day. I can still use it. I haven't trashed it completely. Trashed it. You'll see the 3 teeth there. I chewed out when it bit. You'll see the width of the tooth. It's probably about 2 millimeters. When you clamp down again and that wheel cuts, because of that tooth profile, the width of that profile, you can knock off 0.5 millimeter. You can reclamp it, move it over. You can trim right beside it. This does not flex. It's all laser controlled. It's got all these rings in it, so the plate does not flex. It doesn't. Even if you were to use a bandsaw or similar, a cold saw, sorry, maybe you might get the accuracy, but probably the most accurate thing you could use for this sort of work. Anyhow, that's where I'm up to. I'll just run you through that, sort of go backwards, work my way backwards. I've assembled it all, mocked it all up, test fit the shockeys. I'm really happy with everything. Checked all my clearances. You'll see the bike's now in primer. I did that straight away. We sanded it back. The crew chief and I sanded it all back with 120. Took it right back. Metho wiped the whole lot. As you'll see on the roof, he decided to touch on the ceiling. He decided to hold the ceiling, and now we've got to wash the marks off there. But just primer coated it all, just so it's sitting around. It's not surface rusting. Until I go to just hammer tone paint it. Got the paint the other day with the budget in mind, a grand total of, I think it's $200 for all the paint, plus a lot of other tools as well. Brought some more tools from work, but anyhow, that's where we're sort of up to. And, I'll leave you get on with the rest of your day. Watch the Aussie titles if you get a chance. It's in Western Australia, coming up Easter long weekend. I won't tell you who I got my money on, but I'm hoping Tyler Moon and Brody Cohen. I'm hoping those two. Hopefully, it'd be good to see Tyler do something, and Brody as well. They both put in the hard yard, so good to see them come home with some more chocolates. But otherwise, wish them all well, and you'll have a good Easter. Hope you enjoyed it. We'll catch you next one.